Okay, right then. So what we're going to do now is practice naming and numbering compounds. So this is very important. So first of all, I want to draw your attention to these letters up here at the top of the sheet. IUPAC. IUPAC. We need to know what those letters stand for. So they stand for the International Union of Pure and Applied Chemistry. So there is an international method of naming and numbering compounds so that everybody knows what each compound is. When you're talking about it to someone in China, they'll know exactly what you mean. Okay, so what we're going to do is name organic compounds. And numbering is involved in this as well. So let's have a look at this very first compound here. There's different ways of presenting the compounds. So this is a mixture. This worksheet is a mixture of all of that. So if we had to name this compound, what is it? In order to name a compound, you need to find out how many carbons are in the compound, first of all, and how many are in a chain following one another. So this, even though this isn't a straight chain, this one here, it is a chain of carbon atoms. So I can see the link is going up like this. This one's bonded to that, bonded to that, bonded to that. Okay, so I've got 1, 2, 3, 4, 5 carbon atoms in a chain. There are no double bonds, which means it's an alkane. So this is going to be a 5-carbon alkane is called pentane. So that's that compound. Another way of writing this compound could be, if I was drawing it out, expanding its structural formula, I would do it like this. I'd write CH3 bonded to CH2. This one's bonded to another CH2. This one's bonded to another CH2. And this one's bonded to another CH3. So these two are exactly the same. They're just written or drawn in different ways. Again, 1, 2, 3, 4, 5. 5 carbon atoms pentane. And I can see, look at each carbon. It's got 4 bonds around it. 1, 2, 3, 4 here. 4 around this carbon. There's 4 around this carbon. 1, 2, 3, 4. And around this one, 1, 2, 3, 4. There must always be 4 bonds around each carbon atom. Okay, now let's look at the second one. This one over here. Again, find the longest chain. So there's a chain of carbon atoms here. So this one is bonded to that, and that's bonded to that, and that's bonded to that. So that's 1, 2, 3, 4. So if I follow that chain, I have 4 carbon atoms. Maybe if I started at the top here and went 1 down to here, 1 down to that one, to that one, to that one, it's still 1, 2, 3, 4. It's still a 4 carbon chain. So it doesn't matter where I start, which end I start at. If I start over here, 1, 2, 3, 4, 1, 2, 3, 4. Doesn't matter where I start, this is a 4 carbon chain. So a 4 carbon chain means butane. And of course there's no double bonds. I can see there's no double bonds. So this has to be a butane chain. Right, now I'm going to number. I'm going to number the carbon atoms. Now, if I number the carbon atoms along my 4 carbon chain, if I say this is number 1, this is number 2, this is number 3, and this is number 4, then I can see that attached to carbon number 2, there's this CH3 group here. Now, if you remember from the very first video that we looked at, that we did, a CH3 is known as a substituent group. So something that's added to the chain is a substituent group. So this is my chain, and this is an extra bit that's added. That's a substituent group. And it's a CH3 substituent group. So it comes obviously from methane, CH4. So this means this is a methyl group. So it's a methyl substituent group. I've got to include that in the name. Right. So the real name of this compound then is butane, but with a methyl group attached to carbon number 2. So the name of this compound is 2-methyl butane. Now just before we move on to the next one, I have named that carbon chain, you can see, from left to right, 1, 2, 3, 4. If I named it the other way, 1, 2, 3, 4, then the methyl group would be attached to carbon number 3. So if I came back this way, if I said this was number 1, this was number 2, this was number 3, and that was number 4, then the methyl group is attached to carbon number 3. And I wouldn't go with that option. I would also always go with the option where the substituent groups are attached to the lowest numbered carbon. So always go with the option where the substituent groups are attached to the lowest numbered carbon. Okay, let's look at this one. So this is, we've decided, so this is the name of that second one, 2-methyl-butane. 2-methyl-butane. This one here, we've got, let's find a chain. So we want, if I go left to right, I've got 1, 2, 3 carbons. That's a 3-carbon chain. If I go right to left, it's 3 carbons. If I go up from top to bottom, 1, 2, 3 carbon chain there. If I go around like this, if I go maybe to the left, 1, 2, 3, 1, 2, 2. It doesn't matter which way I go. The longest chain is 3 carbon. So this is a 3-carbon chain, no matter which way I go. I'd always pick the longest chain. So just for argument's sake, I'm going to take this one here, left to right, 1, 2, 3, and I'm going to number my carbons. Number 1, number 2, and number 3. Okay, so I can see it's a propane chain. Propane chain, 3 carbons. On carbon number 2, there's 2 substituent groups. There's this fella here. So anything that's added to the chain is a substituent. I have 2 substituent groups. So the substituent groups are CH3s. And remember, the CH3s come from methane. So these are methyl groups. Methyl groups. And because I've got 2 of them, I've got 2 methyl groups, one at the top, one at the bottom, and they're both attached to carbon number 2. They're both on the second carbon. This is called 2,2-dimethyl propane. So the stem name is propane because it's a 3-carbon stem. Dimethyl because there are 2 methyl groups attached to carbon number 2. It's 2,2. Right, let's look at this one. Here, CH3, then it's got CH2 in brackets 5 times and CH3. So let's draw that out properly to see what's happening. So we've got CH3, then I've got 5 CH2 groups attached. So 1, 2, 3, 4, 5. 5 of them, and again around each carbon there has to be 4 bonds. So I'm just attaching. These sticks are I'm assuming they're hydrogens at the ends of the sticks. And then I've got another CH3 here. Okay, so altogether now I have 1, 2, 3, 4, 5, 6, 7. A 7-carbon chain. All single carbon-carbon double bond, all single carbon bonds. So that means it's a 7-carbon chain. It's known as heptane. So this one is heptane. Okay, let's look at the next one. Again, this is just a straight chain. 1, 2, 3, 4, 5. A straight carbon hydrocarbon chain. It's obvious, nothing strange is happening there. All carbon-carbon single bonds. 5 carbons means it's pentane. I'm just going to call that one pentane. It doesn't have any substituents attached. Okay, let's look at this one. 1, 2, 3, 4. So let's find the longest chain. I can go 1, 2, 3, 4. That's a 4-carbon chain here. Or I could maybe start at this carbon up here and go 1, 2, 3, 4. So it doesn't matter which way I go, left to right, or including this one, it's a 4-carbon chain. So I'll decide on that first of all. And if it's a 4-carbon chain, that means it's butane. Okay, so I'm going to go, just for ease sake, with, the 4-carbon chain just horizontally along there. A attached to carbon, I'm going to number the carbons. Carbon 1, carbon 2, carbon 3, carbon 4, if I go left to right. If I number right to left, that's going to be carbon 1, carbon 2, carbon 3, carbon 4. Now, I have a substituent group attached on carbon number 2. That's a CH3. So a substituent group, of course, is methyl. This time, CH3, a methyl group. And it's attached to carbon number 2. And I'm choosing carbon number 2 because if I go left to right, I'll get the lowest option number available. If I go right to left, that's going to be attached to carbon number 3. So if I go right to left, it's 3-methyl butane. I'm not going to go for that one. I'm going to go to 2-methyl butane. So you always choose the lowest number option. 2-methyl butane. So this is telling me that it's a 4-carbon chain, butane chain, with a methyl group attached at carbon number 2. Okay, let's look at this one. This time we've got 1, 2, 3, 4, 5 if I just go horizontally. So my chain is 5 horizontally. If I go here, starting at the top, on the second carbon, I go 1, 2, 3, that's 3-carbon chain, too short. If I go 1, 2, 3, 4, 5, 5-carbon chain that way, yeah. If I start with carbon here, that one, 1, 2, 3, 4, 5. So the longest chain I can do is a 5-carbon chain. That's my longest option, 5-carbon chain. So that means it's pentane. So I've got pentane stem. Now, I've got a couple of substituents added. Let's see, where are they? So this is my chain now. 1, 2, 3, 4, 5. That's my chain. I'm going to number my carbons. I can number them 1, 2, 3, 4, 5. Or I can go this way. 1, 2, 3, 4, 5. So I can go left to right, right to left. I have to decide which is going to give me the lowest numbered substituents. Okay, so I look at my substituents. So the attached groups, where are they? Here's one. On carbon number 2, I've got a methyl group. There's one. I've got another one on carbon number 2. If I go left to right, another methyl group. And I've got another one here on carbon number 4, another methyl group. So I have a 5-carbon chain, pentane chain, and I've got methyl groups attached, substituent groups attached. So I've got CH3s attached. They're my substituents, so that means they're methyls. Now, how many of them have I got? I've got 1, 2, 3 methyl groups attached, but they are attached now on different carbons. So, on this carbon here, carbon number 2, I've got 2 methyl groups attached. So I'm going to say 2, 2, dimethyl. And then on carbon number 4, I've got another methyl group attached, so 4-methyl. So that's too messy. 2,2-dimethyl, 4-methyl is much too messy. So what I'm going to write is 2,2,4. Trimethyl, because there are 3 methyl groups attached. So 2,2,4 tells me where they are. One of them is on 2, another one on 2, and the third one is on number 4, carbon number 4. So 2,2,4, trimethyl, and of course the chain is 5 stem. So it's pentane. So I wouldn't go for this option. It's too messy. This is the one we're going for. 2,2,4, trimethyl pentane. Okay, now I'm going to move on to the next one, next sheet. What have I got here? I've got a 3-carbon chain, 1, 2, 3, but I've got a double bond. So that means it's an alkene. And if it's a 3-carbon alkene, that means it's propene. So this one has to be propene. Now, we would normally tell which number carbon the double bond is on, but it doesn't really matter in this one, because if I you will always start at the lowest carbon for your numbering for the double bond. So you are going to assume here this is carbon number 1. 1, 2, 3. Which means this is prop-1-ene. If you put the numbering at this side, 1, 2, 3, that means that your double bond would be on number 2 carbon, and you wouldn't go for that option. So this is prop-1-ene. Prop-1-ene. Okay, you've got no option actually, is what I'm trying to say. No matter if you put the double bond here or there, it's always going to be prop-1-ene. Have a look at that, make sure you understand that. Here we've got another alkene. How do I know it's an alkene? Because it's got a double bond. Okay, 1, 2, 3, 4 carbons, which means it's a butene, 4 carbon chain, butene. Now, I'm just going to say where that double bond is, so I'm going to number the carbons. I'm going to say carbon number 1, carbon number 2, 3, 4. If I were to number it the other direction, right to left, this would be carbon number 1, carbon number 2, carbon number 3, carbon number 4. So it doesn't matter which way I number, whether I go left to right or right to left, the double bond is always on carbon number 2. So it's the carbon where the double bond starts, carbon number 2 here, and if I number that way, carbon number 2. So just by default, I'm going to go that way. That's my chain. So that means on carbon number 2, we have a double bond. So it's but-2-ene. But-2-ene. Okay, look at this one down here. I'm going to find out which is my longest chain. Identify the longest chain. So if I go horizontally, 1, 2, 3, 4, 5 carbons that way. If I start up here and go 1, 2, 3, 4, 5, that's 5 carbons as well. If I start down here, 1, 2, 3, 4, 5, that's my longest chain. So no matter which way I go, I've got a 5 carbon chain. So that means it's a pentane. All single bonds, it's an alkane. Now then, if this is my chain, 1, 2, 3, 4, 5, that's my chain I'm choosing. I've got a few substituent groups attached again. I've got, actually is this the same as the other one? I've a CH3, a CH3 and a CH3. So I'll number my carbons now. 1, 2, 3, 4, 5. And again, this is the same actually as the last one, girls. I've got methyl groups attached. I've got 3 of them, so it's a trimethyl. Trimethyl pentane. And then tell the number of, or identify which carbons have the methyl groups. So I've got 2 on carbon number 2 and 1 on carbon number 4. So it's 2, 2, 4. 2, 2, 4, trimethyl pentane. Okay, look at this one over here. Again, I've got 1, 2, 3. This is actually the same as that one, so I won't bother doing that. Right, draw the structural formula for cycloheptane. Okay, cycloheptane. Heptane means 7 carbons. And it's a cyclo, which means it's a ring compound. So I'm going to put 7 carbons in a ring shape here. 1, 2, 3, 4, 5, 6, 7. And then I'm going to join them all by double bonds because it's a heptane. And then I'm going to attach hydrogens, 2 hydrogens at each carbon. Why 2? Well, I put 2 hydrogens here. Remember, each carbon must have 4 bonds around it. So that top carbon now has 4 bonds. If I attach 2 carbons here, you can see when I put 4 bonds around, two extra hydrogens, I have 4 bonds around that carbon. So each one here is going to be 4. And you can see it's a little bit messy when you do that, when you do it like that. So you have an option, which is normally what you see. You just draw a shape like a 7-cornered figure. So this is fine as it is, that's fine, except it's a bit messy looking. So we could draw it like this. So each vertex represents a carbon with the corresponding number of hydrogens. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So if you count the vertices in that shape. 1, 2, 3, 4, 5, 6, 7. That's the same as that. And if you were looking at that, an organic chemist looking at that would know that that's what you mean. You've got a 7-cornered figure, which means it's a 7-carbon chain. Now, heptane, if you remember what heptane is an alkane. So there's 7 carbons. I'm just going to write that up here. Heptane is C7. And because it's an alkane, its general formula is CnH2n plus 2. So this would be H2n plus 2, 7 2s are 14 plus 2, H16. But look at cycloheptane. How many hydrogens does cycloheptane have? It has 2, 4, 6, 8, 10, 12, 14. So cycloheptane formula is C7H14. So it has 2 hydrogens less than the heptane, straight chain heptane. And that's because you lose 2 hydrogens when you're forming an extra covalent bond there. Okay, so something interesting point just to be aware of. When you do change something into a cyclical compound, you lose a couple of hydrogens. Okay, cyclohexene. Hexene means that there's 6 carbons. So 1, 2, 3, 4, 5, 6. Join them all by covalent bonds, but because it's a cyclohexene, one of those is going to be a double bond, so I'll put that there. You can attach then the corresponding number of hydrogens to each carbon. So this top carbon already has 3 bonds around it, so there's only 1 extra hydrogen attached there. This second carbon already has 3 bonds around it, so there's only 1 hydrogen attached there. This carbon down here now, that has 2 bonds around it, so you put 2 in here, 2 go into this one, an extra 2 in here, and an extra 2 in there. Again, that's a bit messy looking. So we don't normally write cyclohexene like that. What we would do is write a 6 vertex shape, and we'd put one of those bonds as a double bond. So that means cyclohexene. Okay, what's hexene? What's the formula for hexene? Hexene has 6 carbons, and remember the general formula for alkanes is CnH2n. So hexene is CnH12. However, when you turn it into a cyclo compound, you now have 2, 4, 6, 8, 10 carbons. So cyclohexene is C6H10. Again, just be aware of that cyclical effect. Okay, 2 ethyl, 1 pentene. So let's actually draw the structural formula for this now. So we're starting off with a 5-carbon chain. Pentene means a 5-carbon chain. 1, 2, 3, 4, 5. The 1 pentene means that the carbon-carbon double bond is on number 1 carbon. So I'm going to assume this is number 1 carbon. I'm going to put it on there. So this is my carbon number 1. We would normally, sometimes you see this written as 1 pentene, which means the double bond on carbon number 1. Or sometimes you see it written as pent-1ene, which means the double bond is on carbon number 1. Either one will do. On carbon number 2, there is a substituent group. So this 2-ethyl indicates a substituent. So I'm going to put here on carbon number 2, I think that should be methyl actually sorry, that should be methyl. 2-methyl. So on carbon number 2, I'm going to put a methyl group. Methyl group is CH3. So let's have a look. I'll fill out then the leftover carbons, so hydrogens. So on this carbon I have 2 bonds, I need another 2. On this carbon I have 1, 2, 3, 4 bonds around that carbon, so I don't need anything else on that one. On this one I've got 1, 2 carbons, so I'm going to put an extra 2. This one I need an extra 2, and this one I've only got 1 bond so far, so I'm going to put 3. So this is my 2-methyl pent-1ene. Look at this one, 2,3-dimethyl but-1ene. Okay, so again, bute means it's got a 4 carbon stem. Butanene is my 4 carbon stem. On carbon number 1, I've got a double bond, I'll put it there. And attached to carbon number 2 and 3, there are methyl groups. So dimethyl means 2 methyl groups. So I'll attach them to carbon number 2 and carbon number 3. So I'll put a methyl group here and a methyl group here. And then everywhere else, I will just fill in the hydrogens. So carbon number 1 at the moment just has 2 bonds, so I need another 2 bonds around that. Carbon number 2 has 4 bonds, not adding anything else on there. Carbon number 3 has 3 bonds, so I need another hydrogen on there. And carbon number 4, I need to put 3 bonds on there. So this is 2,3-dimethyl-butanene. And then the last one, name and draw C2H4. So C2, I draw 2 carbons. H4, only 4 hydrogens are going around this carbon. So I'll distribute them evenly because I'm not told anything else here. So I'm going to put 2 hydrogens on here and 2 hydrogens on there. Okay, remember each carbon has to have 4 bonds around it. So look at that first carbon there. You've got 3 bonds only, and this second one only 3 bonds. So I'm going to have to put a double bond in there. And of course, this is the first member of the alkene series, so it's called ethene. Okay.